Hey, hi, hello guys, welcome back to Code with Nani channel. So today we're going to discuss Leetcode problem of the day, which is maximum candies allowed to allocated to a k children. So you are given zero index array candies. Each element in the array denotes a pile of candies, which is a stack of candies, or some you can assume something like that. You can divide each pile to any number of subpiles, but you cannot merge two piles together. So which is basically this, right? Suppose if you are given a 10 pile of candies, so you can divide it into 5 or you can divide it into 8 2, or you can divide 6 4, something like that. You can divide the piles, but you cannot merge. Suppose you want a 10 candies, but you cannot pick 5 candies from first candy and 5 candies from second candy, and you cannot merge it and make it 10 candies. So what they are trying to say is you can divide a single candy, but you cannot merge two other candies. Okay, so you are given integer k, so you should allocate piles of candies to k children. So you should divide these candies into a k number of children, such that each child gets the same number of candies. Okay, each child should get the same number of candies. So each children can be allocated candies from only one pile of candies, and some of or leave it. Return the maximum number of candies each child get. So we just need to return the maximum number of candies that each child will get. So you can use one pile of a candies, and some piles of candies can go unused, which means like you can use some of the candies, and if there are leftovers you can left it, but in the end you should return the maximum number of candies such that each child get the maximum number of candies. So I'll give an example, you'll get clarity about that. So basically, what they're trying to say is, suppose you have a candies of 5, 8, 6, and you need to divide these candies into three children. Suppose, suppose you choose a number as 6. So you need to divide uh, these candies to a three children such that each will get a 6 candies. So for that sake, so we have a three people. This is person one, this is person two, this is person three. So you give this 6 to this guy. Okay, so this guy fulfilled with 6 candies, right? And we have 8 candies. So out of 8, we'll divide 6 and 2. So we'll give these 6 candies to this guy. Okay, and this guy is also filled. So what are so we are left with another guy, but we only have a 5 candies. Okay, we cannot distribute 5 candies from here and 1 candy from here, as they already told you. So you can divide a single pile, but we cannot merge two other piles together. So that will be a wrong case. Suppose in other case, suppose in other case, what you can do is, what you can do is, we have a 5, 8, 6, right? So divide this with 5 and 3, and divide this 6 with 5 and 1. So give these 5 candies to this guy, and give these 5 candies to this guy, and these 5 candies to this guy. And we are left over with 3 candies from the second candy, and 1 candy from the sixth candy. But still, it is a solution, because as they already told you, so you can select one of pile of candies, and some pile of candies may go unused, but we need to return the maximum answer, which is 5 in this case, because we cannot make it a 6, because when you try to make a 6, we cannot distribute all the candies to this three people. So maximum is 5. So if 5 is possible, 4 is definitely possible, because as the candies are 5 8 6, you can distribute using a 5, then we can definitely make it is 4, right? 4 1, 4 4, this will be 4 2. So we'll give these three candies to the three different people. So if 5 is possible, definitely 4 will be possible, 3 will be possible, 2 will be possible, 1 will be possible, because we can divide each other candies as well. So if you get this intuition, then you can easily solve this problem. Suppose if we had a specific element, so which means if suppose if there are n candies, let's just, like, we don't know this number, which is n some x candies. So we don't know the number, we have x candies. Suppose suppose anywhere in between this, which is x minus suppose the k candies. If it is possible, then all the left side part, so all the left side part definitely will be possible. But what we need to return, we need to return the maximum value. So if this is possible, we don't check this part. Why? Because if it is possible, then what will be the chances? This can be a maximum, or the right side part can be a maximum. So definitely this won't be our answer, right? Because it shouldn't be a maximum value, because there is a greater element than this left part, right? We have this element as a greater element. So what will be the case? Either this will be our answer or right side will be the answer. So if you find any particular element that supports the distribution of the candies to the children, then definitely right side part will be your answer. We shouldn't go for search for the left part. Okay. Another case. Another case. Suppose this is x minus k and this is x candies. 1, 2, 3, 4, 5. Suppose if we try to solve this problem, we try to use this x minus k candies to distribute the children. So if it is not possible, as we see in this previous example where 6 is not possible, then definitely 7 won't be possible, because even 6 we can't able to distribute to the children, and how come the 7 will be able to distribute candies to the children? So that's the case. So if x minus k is not possible, then we shouldn't look over this right side part of the array. Definitely this will not be possible. So what we can do is we'll check for the left side part of the array whether there is a possibility that we can able to distribute those candies to the children. So if we carefully observe what we are doing, we are doing a binary search. So we'll check for a mid element. If mid is possible, then we will check on the right side. We shouldn't check the left side because we need the maximum answer. So if mid is the value, then there will be a case mid can be answer, or right side part of the array can exist an answer that is greater than the mid. Or else if mid is not possible, then definitely right side of the mid is not possible, because there is no possible solution that exists to distribute all the candies to the children. So if mid is not possible, then definitely right side part of the array is not possible. So we shouldn't, so no point in traversing the right side part of the array. So if it is not possible, check out the left. If it is possible, check out the right to get the maximum answer. So that's the intuition behind this question. So let's just run through the code. You'll get clarity around the question. So, so this is my code which I used to solve. So basically, I'm initializing the left would be 1 and the right would be the maximum. We don't know whatever the minimum. I'm just initializing with 1e9, which is 10 power 9, and answer 0. There might be a case. There might be a case. Here we only have a 7 candies, but we need to distribute to the 11 people, which is not possible in this case. So in this case, we will just return the 0. So for that case, I'm just initializing answer with a 0, while left less than or equal to 1, we'll check a mid element. So what I'm doing is if check is a boolean function which returns whether for that particular element whether it is possible to distribute to the all the candies to the k children or not. If it is possible, we'll store it in ons, and if mid element is possible, then we no need to check on the left part of the array, which is like we need to get the maximum answer, right? So we only check on the right side part of the array. That's what I'm doing. So if mid is not possible, then definitely right side of the mid cannot be possible. Then what I'm doing is I'm just traversing on the left side part. That's what I'm doing. Right can be mid minus 1, and in the end return answer. So we'll write a logic to this check function which does the check whether it is possible to distribute to among the k people or not. So I am more convenient in writing the lambda function because we don't need to pass this parameters, so huge parameters like vector. We need to pass this candies, and we need to pass this k as well. So I'm just more convenient in writing lambda function. So it is inside of that function scope, so we can skip about that. So that's why I'm using this lambda functions. So auto check, which is a boolean function, and taking a parameter as a mid element. So I'm just counting it like how many uh, people that we can accumulate using this mid element. So I'm just iterating through the candies. If current element which is greater than or mid, then in that case count plus equal to I by d. Suppose if mid element is 5, which means we are checking whether five candies, using 5 candies we can distribute among all other children. Suppose the suppose in that candies vector it is value which is 10, so we can distribute that 10 into two children, right? 5 comma 5. So that's what I'm doing. How many people we can count, that will be the current element by the mid element. Suppose if the current element is 4 but the mid element is 5, so we cannot distribute that 4 candidates to the each person, right? So if in that case 4 by 5, which is 0, so the count will be added as 0. So that's what I'm doing. If I is greater than or equal to mid, then only we are adding it to the count. Return, we need to return whether it is possible or not. When you say it is possible, if the current count is equal to k or even more than k, or you can even distribute to the more people, which means we can left it leftovers, but if it is can distribute to the more than k people, then in that case we can just return the true. So if the count is more than k or equal to k, we can return true, or else it will return the false. So that's what we'll do. Just run the code. Let's see, it's running. Hola, it's submitted. And that's it for today video, guys. So if you like my explanation, do subscribe to my channel and hit that bell icon, and you never miss any notification from my channel. And if you have any queries regarding my explanation or regarding the code, do put it in the comment section. Or if you have any optimized code, feel free to put it in the comment section. I'll review it. And that's it for today video, guys. Thank you. Tata. Bye bye. See you tomorrow with a great content. Bye bye.